Hello. In this video, we are going to be doing a little bit of atomic structure review. So briefly reviewing protons, neutrons, electrons, how to look at the periodic table and know how many protons, how many neutrons, how many electrons something has in it. The reason why we are reviewing this now is because our next unit is nuclear chemistry. Nuclear chemistry is reactions that involve changes in the nucleus. So we will need to refamiliarize ourselves with the structure of the atom and protons, neutrons, and electrons in order to be able to be successful in that unit. So we have our protons, our neutrons, our electrons. So those are our subatomic particles. Our protons are positive. They're located in the nucleus and they have a mass equal to 1 AMU. So their mass is about the same as a neutron. Neutrons are also located in the nucleus, and neutrons are neutral or they don't have a charge. And then lastly, we have our electrons. Our electrons are located outside of the nucleus. They are negatively charged and they have a mass almost zero. So it would take almost 2,000 electrons to equal the mass of one proton. So electrons are essentially massless. All right, so you want to have your periodic tables handy. So if we take a look at our periodic table, let's say we have chlorine, so Cl, and the atomic number is the bold number in the lower left-hand corner. So atomic number for chlorine is 17, therefore chlorine has 17 protons. Then the top number is going to be the mass number. The one that is given on the periodic table is a weighted average of the different isotopes that naturally occur. But if we have a number written here, this would be the mass number for that particular isotope. And that's equal to protons plus neutrons. So if we are working with chlorine with a mass of 35, since it's chlorine, we would have 17 electrons because atomic number is 17. If the mass is 35 and we have 17 protons, then we would have 18 neutrons. So that together they add up to 35. And then our electrons will be equal to 17 because for a neutral atom, no charge, the number of protons, the positive charges, must be equal to the electrons, the number of negative charges. All right, we have isotopes and ions. So ions are when we gain or lose an electron. So if we have something like aluminum with a +3 charge, regular aluminum, if we take a look at the periodic table, would have 13 protons and 13 electrons. So if this charge wasn't here, it would have 13 electrons because it has an equal number of positives and negatives. But with the +3 charge there, that means we have lost 3 electrons, so now it has 10 electrons. So positive ion, you lose electrons. Negative ion, you gain electrons. Then we have isotopes. Isotopes are the same element with different masses, such as carbon-12 and carbon-14. So if we take a look at carbon-12 versus carbon-14. Okay, we find carbon on the periodic table. Carbon has 6 protons because atomic number is 6. It would also have 6 neutrons because the mass is 12. And electrons, I don't have much space for the electrons, but electrons would also be equal to 6 because 6 positives, 6 negatives. All right, carbon-14 would have 6 protons because the atomic number is 6. The neutrons here would be 8 because 6 plus 8 equals 14. So when we have a different mass, the number of neutrons changes. Electrons would still be 6 because it still doesn't have a charge, so therefore we need 6 positives, 6 negatives. So we just have a couple of examples to run through just to make sure that we remember how to do everything. So we have uranium 238. So 238 is the mass number. Atomic number is the bold number on the periodic table. So we find uranium. Uranium is in that bottom section of the periodic table, which we will be using more in this unit when we're doing nuclear. Atomic number is 92. Since the atomic number is 92, the protons must also be 92. And since this is not an ion, this is an atom, it is neutral. So if we have 92 positive protons, we need to have 92 negative electrons. In order to figure out the neutrons, I'm going to take the mass, 238, minus 92. So mass minus the protons will give me the neutrons, which will be 146. In this example, we have an ion. So we have K, which is potassium. Mass is 39, so that top number there is the mass number, and it's a +1 ion. So we find K on our periodic tables. Over in group 1, so the atomic number is 19. Protons would also be 19. Neutrons would be 20 because we do the mass minus the protons to give us the number of neutrons, because protons plus neutrons equal the mass, since they both have a mass of about 1 AMU. And electrons, if there wasn't the charge, would be 19. But since we have a positive ion, that means we have lost an electron. So now we have 18 electrons. So we have 19 positive charges, 18 negative charges, and that's what gives us the overall charge, +1. All right. Br with a mass of 79, so mass number 79, charge is -1. So first thing we do, find bromine on the periodic table. Bromine is over on the right-hand side in group 17. We have an atomic number of 35, therefore 35 protons. In order to figure out the neutrons, we take the mass, 79, minus the number of protons, and that would give me my neutrons as 44. Then electrons, if this was a neutral atom, 35 protons, 35 electrons, but this is not a neutral atom, it's an ion. We have a -1 charge. Negative charge means we have gained electrons, so this has 36 electrons. Couple of multiple choice questions. So the atomic number of any atom is equal to protons. Atomic number will always tell you the number of protons. Okay, carbon 12, carbon 13. The carbon 13 has a higher mass because it has 1 additional neutron. If it had another proton, they wouldn't be carbon because then they wouldn't have an atomic number of 6. And if we change the number of electrons, then we would produce an ion. Number 5, which of the particles has the least mass? So that would be an electron. Electrons are essentially massless. All right, and our next one, we're looking for which 2 are isotopes. Isotopes are the same element, so same number of protons, but they have a different mass because they have a different number of neutrons. So choice A will not work because those are not the same element. Choice D, also not going to work because those are not the same element. Choice B is going to be our answer. Oxygen, oxygen, mass of 16, mass of 18. Choice C doesn't work because they're totally the same thing. They are not different isotopes. They are both the exact same particle. All right, number 7, chlorine 35. So we look up chlorine on the periodic table, and chlorine has 17 protons, so not C, not D. Neutrons, if the mass is 35, would be 18. 35 or 17 plus 18 equals 35. And electrons would also be 17 because it's an atom, therefore it's neutral, so has an equal number of protons and electrons.